Okay, now we're going to do the sort of double integral that is typical for probability. We've got this region in the xy plane, and let's suppose it's the region between the curve y equals x squared and the curve y equals the square root of x. And let's call this region R, and we want to do the double integral over R of x times y dx dy. So, as with all integrals are limits of sums. You get them by slicing them into little pieces. So we first slice our fish-shaped region into some vertical strips, and then we say, what is the integral of xy over each vertical strip? Well, each vertical strip starts at the bottom at y equals x squared and goes up to y equals square root of x. So this winds up being the integral as y goes from x squared to the square root of x times y dy. This integral gives you the contribution of each strip. Then you put all the strips together, and the strips run from x equals 1, x equals 0, all the way to x equals 1. So we integrate as x goes from 0 to 1 of this expression. Okay, so let's do it. For each vertical strip, x is basically a constant. So it comes along for the ride, and we get xy squared over 2, evaluated at x squared and at square root of x. That's this integral. Whoops. Left out a dx. That's this inner integral, gives you this, and that's what we're integrating from 0 to 1 dx. So we plug in y equals square root of x, and we get x squared over 2. Plug in y equals x squared, and we get x to the 5th over 2. X squared times x is x to the 5th. And we're integrating that from 0 to 1. And that just gives us x cubed over 6 minus x to the 6th over 12. Evaluated at 0 and at 1. So that gives us 1/6 minus 1/12, which is 1/12. So in this case, the integral happened to be 1/12. But the important thing is understanding how to integrate over regions. You integrate regions by chopping them into strips. In this case, we chop them into vertical strips. You integrate over each strip. That gives you an integral from y over y as y goes from the bottom value to the top value. So the bottom limits and the top limits for y are functions of x. But once you know the contribution of each strip, you have to add up all the strips. And then x goes from 0 to 1. The outer limits of integration are numbers. The inner limits of integrations are functions of the outer variable.